Covariance is often denoted by COV and it describes the relationship between two variables. Let's say we have two variables x and y. So covariance of x and y is negative if one variable increases and the other one decreases. And it will be positive if both decreases or both increases together. The value of covariance could be anywhere between minus infinity to plus infinity. After that, we have something called covariance matrix. Covariance matrix gives us the information about covariance between the variables, which is shown by orange rectangular boxes. These are the values for covariance between the variables. And the values shown by the green boxes is the covariance within the variable. So this entire matrix is called as covariance matrix. Now once we know that the relationship between variables is positive or negative, then the next question is how strong the relationship is. So to know the strength of the relationship, we use something called coefficient of correlation. Coefficient of correlation is used to find how strong a relationship is between two variables. Its value varies from -1 to +1, that is strongly negative to strongly positive. And the value of 0 means no relation at all. Now the formula for COV, that is covariance, is given on the left hand side for population and sample respectively. And the formula for coefficient of correlation is given on the right hand side for population and sample respectively. Now you don't have to mug up these formulas, just take a look so that you are aware of it. All these calculations will be done by the software, so we should just be aware of these formula. Now again, the benefit of using the coefficient of correlation over covariance is that the value of coefficient of correlation lies between -1 to +1 and the value of covariance lies between -infinity to +infinity. So in short, covariance tells us the direction of the relationship, whether it is positive or negative, and coefficient of correlation tells us the strength of the relationship along with the direction. Now let's move on to the next concept. Next we have outliers. Now outlier is an observation that is at an abnormal distance from other points. So as we can spot in the below figure, there are two observations, -70 and 95, which are outliers. Because -70 is an extremely low value compared to other values and +95 is an extremely high value compared to rest of the values. However, outliers are not always so obvious, and we use methods like box whisker plot, interquartile range, etc. to detect outliers. We will see box whisker plots when we will do exercises in R, but for IQR we can just see the formula here. These are the formula that we use to find the outlier using IQR method. So any point that lies beyond these limits will be considered as outlier. Then our next term is statistical noise. So statistical noise is nothing but random irregularity that we find in any real life data. They don't have any patterns and consist of errors and residuals. Now error could be due to false measurements or wrong sampling. So it is the difference between actual value and the measured value. And the residual, as the name suggests, is the remaining part. Basically, when we will do modeling in our upcoming modules, then we'll train our model on a part of our sample. Let's say 70% of the observation we use for training the model. And then we'll test the model on the remaining 30% of the observation. So residual will be the observed value in the test data minus the predicted value by the model. We will see this later on in the modeling in detail. So for now, just understand that residual is the difference between the observed value and the predicted value. Now the last important concept is the standard error. So what it tells us is that how far a sample statistic such as sample mean, standard deviation, etc. is deviating from our actual population parameter, which means population mean or population standard deviation. So basically, let's say we have standard error of mean. So it will tell us if our sample mean is say 10, then how far it is from the mean of the population from which we have taken the sample. Remember, we are studying the sample to conclude about our population. So we must know how accurate our sample statistics are. So that is the reason we use standard error to understand the deviation between the sample statistic and the actual population parameter. Now obviously if you have a larger sample size, then the standard error will be less. And in statistics you will come across terms like standard error of mean, standard error of median, etc. The formula is given below, but standard error of mean is the most commonly used term. So here in the formula, sigma is the standard deviation and n is the number of observations.